Okay. Now, if you're not, just unmute and tell me because I can't see the chat box. A section students, can you see the screen? PPT? Class CR, unmute and answer.
Yes, ma'am, it is visible.
Visible. B section, Ksham, it is not visible. Is it? A section students, please bear with me for a few minutes. Now for B section, is it visible? For B section also it is visible, no? Okay, okay. So for both it is visible. I can move on, I think. A and B. Yes, yes. Okay, okay. Fine. Now, today we will start with the fifth module, that is communication protocols. Okay, so in this protocol, when we study, not all the layer protocol we are studying. Okay, we concentrate on physical layer protocols. So in that, physical layer and transceiver design considerations in wireless sensor network. So if we segregate that into two parts, okay, what we study in this module, first we will be studying about physical layer, okay, and modulation and demodulation techniques, and what are the limitations in that, okay, how to overcome that. uh, so those things we will be studying. In the second part, we are concentrating, like we are confining our design to only wireless sensor networks. So like this we will be studying. So here it is completely theory, okay, but uh, topics according to me are not very new to you. We are clubbing the topics which we have studied till now. Different subjects we have studied, so those topics we are clubbing it here. Okay. Now, in physical layer when we study, okay, so fine. What and all things we have to see? First is low power consumption. Okay, it has to be like, then small transmit power. Okay, so small transmission range. See, these are some of the things we need to consider. I will be talking about power. Even you have to consider about the power. But when power, when we make it small, automatically it reflects on the range of the antenna. Okay, so transmit power, if it is low, the antenna range is automatically small. If the antenna range is small, then my communication becomes very narrow. Okay, that is for a short distance only I can communicate. I cannot communicate to a longer distance. So all those things we have to, okay. Then a low data rate. Data rate we have to see how much it should be. Okay, and duty cycle. So this actually, these are some of the things which we look for wireless sensor network design when we do. Now, coming to that first part, that is physical layer, low implementation, that is complexity and cost. Okay, now coming to that first part, that is physical layer, there actually we have to talk about frequency allocation. So first you need to know what is this frequency allocation. So I think this topic, those who have done some small projects, you might be knowing. Otherwise, like you don't know the frequency allocation. This is a new topic to you. So how this frequency is getting allocated? Who is allocating the frequency? Can I work in any frequency which I want? So these are the questions, because the spectrum what we call uh, is limited. Okay, spectrum is limited, or you see frequency band, that is limited. Okay, electromagnetic em spectrum, that I cannot extend, like whichever number if I tell, I cannot get that. The main problem, why cannot I get is like generation is a problem. Okay, propagation may not be that this thing anyway. Medium conditions I need to consider, but generation itself is a problem. Okay, so what we want to do is, in the whatever available band, or the, yeah, available spectrum, we want to put every application what we want to do. Okay, so now how, and we don't want others to interfere my transmission. That is also there. So somebody has to allocate me one completely dedicated frequency band. Frequency band is a range of frequency. Okay, that they need to allocate. Yes, that is why internationally, if you see, international telecommunication unit, ITU is there. Okay, to allocate those frequency bands, whereas in India, if you see, it is in our country, it is TRAI, TRAI. Okay, TRAI is there, which allocates the frequency band. So the government has to give the permission, okay, to use those frequency bands. Okay, otherwise we cannot use. Okay, it will become illegal, because that frequency band would have been given to somebody else. So if you're using that frequency band, then actually it is interference. You're hacking their data. So which is illegal. That is why, and some frequency band is kept for what you call general purpose, or it is for any use. Okay, that is called as ISM band. Okay, industry, scientific, medical band, ISM band. Usually what we work, that is 2.4 gigahertz. Okay, where, like, hotspot is also in that range only, or whatever you do applications now is in that band only. Okay, because in that band, if you are working, you don't have to wait for anybody's permission. Okay, you just go and bring the module. Okay, communication module, whichever you want. Okay, uh, even the Bluetooth also works in that only. Whichever transmitter module you want, you bring that and start communicating. So it uses that module uses the freely available module uses, unlike freely in the sense unlicensed, I mean, these ISM band only. Other than that, okay, now if you see your mobile frequency band, no, that is not unlicensed, that is licensed. Okay, SIM card. So when you purchase a SIM card, it is allocated to one particular frequency is allocated to it. Sorry, and that will not be allocated to anybody else. So like that, frequency band, licensed and unlicensed we have. Now if you see frequency band, like this is not new to you. We have very low frequency range, medium frequency, high frequency, then again very high frequency, ultra high frequency, super high frequency, extremely high frequency. So these are the few, like, broadly categorized. If you look into different books, you get different bands, no problem. Some will start from X-rays itself. Okay, some will name it as some this thing. So that should be okay. You may find millimeter range, micrometer, so like that. Okay, now what I wanted to say, that yeah, these are the, for wireless communication we use. Okay, these many till that is 300 gigahertz, extremely high frequency for wireless communication. But what about after 300 gigahertz, can't I use? Yes, we can use, but that will go for the wired communication, optical, okay, infrared. So like this, so those range, that will go up to 12 terahertz. from 3 gigahertz it will go up to 12 terahertz. So that range can be used in for communication, but the medium of transmission will be different. So because each all those things, different frequencies will behave differently in different medium. So suitable medium you need to select for transmission. See, all these comes in physical layer only. Okay, when we talk about the next layers, higher layers, we don't have to consider all this, because data would have come to my hand. Data would have come to my hand in the receiver, okay, from the physical layer. Then I am processing it. Only that part is left out. But here, when we talk about the physical layer, all these things comes. However, channel model also comes in this only. How am I supposed to select the channel? What type of channel is it? It should be. So okay, or if sometimes I have no options for channel. If you may wonder, what is she talking about channel? When I'm working in wireless communication, it is air medium only, environment only is the channel. Yes, in that channel I should find out what is the loss. Okay, for my signal, you think that I am using low frequency LF, okay, and I'm sending it. So my I have one transmitter, one antenna, and on the other side I have one receiver. Now I should find out at what distance I should keep the receiving antenna. Okay, is it okay if I keep it 10 kilometer away? Is my given from the uh, signal given from the transmitter will be received at that end without much corruption or decaying? Okay, is it will I able to get it? If not, how much I should reduce? Should I reduce it to, yeah, I can take randomly, okay, let me reduce it to 5 kilometer. Okay, cost is involved in it. 5 kilometer means to transmit 10 kilometers I have to use 3 antennas. Okay, so how much should I reduce it? Okay, the same medium, that is the environment, is used for another person, but he is using in a super high frequency, SFH, SHF. Okay, so for his transmission, because his frequency is different, maybe he is able to transmit to a 15 kilometer without any repeater in between. Okay, so these are actually channel modelings. How my channel, I should find out the losses in the channel per kilometer, okay, or per mile, per meter, how much is the decaying. Okay, so this I have to look in, one factor which I have to look in the channels when I'm designing the physical layer. Next, coming to one more thing is, yeah, licensed band. In the licensed band, if you see the GSM, okay, now actually we have gone to 3G, 4G and all, but GSM, which was the base for all these. Okay, so there actually the dedicated band is kept. So GSM 900 means the range is from 880 megahertz to 915 megahertz. So that is exclusively for the mobile communication. Okay, in some of the countries, most of the countries, GSM 900 is used. Another band which is used is GSM 1800. So there actually range is from 1710 to 1785 megahertz. So that is called as 1800. So that range. So that range is exclusively allocated for mobile communication. It is licensed. So nobody else can enter there. Okay, nobody else can enter that range. So like this, licensed version and unlicensed, the regulations will be there. Okay, and we have to go with the regulation. And those who want any wireless, then you can ask, what about the IoT applications? IoT applications, if you're doing that, ISM band is there. Okay, now what is the in the ISM band, don't we have the interference, don't we have the crosstalk, all those things will be there. Okay, that we will discuss later one by one. Yes, those things will be there, other than channel decaying. Like a channel decaying anyway will be there, and that will be there for the licensed band also. Other than that, actually, we have interference and all. Okay, when we are using the free band, so that time actually protocol varies. Okay, protocol varies, your encoding type, all those when we get the module itself, encoding type, security type, everything varies in that. Okay, so in that way we can use. So IEEE 802.15.4 WPAN also uses, Bluetooth uses. So all these okay, are in the what you call unlicensed path. Next, coming to antenna efficiency. Okay, so what is this antenna efficiency? When I'm considering the physical layer, I should antenna parameters is the one of the like major considerations in the design aspects. So what is this antenna parameters? Now you might have, I don't know, in physics or in basic electronics, when you learned about the basic communication thing, you might have heard antenna height is proportional to the wavelength. Okay, this is one very common design aspect. Antenna height is proportional to the uh, wavelength of the data what we are sending. That is why the wavelength have to be converted. Okay, if you are using any other okay voice signal or anything, the you have to modulate it to that wavelength in which antenna can propagate um, correctly. Okay, now when I'm talking about wireless sensor network, okay, I am going for very compact thing in that okay entity. In that actually, if the antenna height itself is a hurdle, okay, if you tell me that okay, I want to have a 15 centimeter antenna. Okay, I want to have around one like 100 centimeter antenna. So in that way, if you tell, then how actually we can design? Only antenna will be like very large compared to my all other devices. So that is not possible. So if I reduce the antenna, then again my wavelength has to be reduced. So how the trade-off has to be done? Okay, when I reduce the height of the antenna, what happens is the length comes down. Okay, and the radiated power, I mean, it affects the radiated power. Okay, that is like very directly proportional, radiated power. So I cannot think of putting very high power to the antenna transmission. Okay, so it will become very costly. Okay, those equipments and so high, very high power we cannot. With low power, okay, very low power is also not possible. But at the receiver side, the receiver antenna should be designed, it should be so sensitive to receive a very feeble signal, because in the medium, in the channel, it would have got degraded. So minimum power only I will be expecting, and it should be able to receive that, and it should be able to decode, demodulate, and so on. Okay, but I'm talking about there it is okay. Only I should consider about the sensitivity of the receiver. But when I'm coming to the transmission part, antenna power, okay, how much we can give antenna power is a matter. Okay. Now, so again, there will be a trade-off. Okay, when what type of antenna, how much power are we giving? When we give so much of power in this frequency band, what is the decay? That is a degradation in dB, because it dB is not only, it is not uniform for all frequency bands. It varies from frequency to frequency. So which is this thing, what is that frequency I must select? So all these also we will be considering in the antenna efficiency. Efficiency is antenna efficiency. You will be studying in detail, but if you want me to define it, is like antenna radiated power, ratio of antenna radiated power to the antenna input. Okay, antenna input. Yeah, you may wonder, then where will be the loss? Why should be there loss? Loss will be there. Okay, it is every system. It is like that only. No, we give input and we get almost the output. there won't be any much of loss in the system which we are like having in hand. Here, why is it? Here the loss is more because the electrical signal what you are giving as the input to the antenna is getting converted to electromagnetic waves. The form itself is changed. Okay, so in during that process, loss will be there. Okay, and where is loss goes? It is just as radiated as heat and the on antenna equipment. Okay, it is just left to that energy is just left to the environment. So that loss that is a very like one of the major this thing you need to consider, not like any other component or equipment antenna. Okay, I hope I'm made it clear. Why do you have to consider antenna efficiency so keenly? Because it is converting from electric wave to electromagnetic wave. So in that process, loss will be there. Okay. So that is one part. Okay. Next, coming to modulation and demodulation schemes. Okay, and that is also the job of the physical layer only. Okay, when designing the physical layer, we need to consider the modulation and demodulation techniques. Now, we have learned many modulation techniques. So, whatever modulation we use, same demodulation we will be using at the other end. Okay. Now, in that, what parameter we need to consider? Can I select any one this thing? No. First thing is it shouldn't be what is that? Circuit shouldn't be so complex. First part, okay. Second part is what is the symbol rate, what is the bit rate, okay, what is the error rate, all these things we need to see. Okay, so symbol rate and bit rate, if you ask me, it is like you know what it is per second, how much bit is passed, that is bit rate, anybody can say that. Okay, then what is symbol rate? Okay, sometimes you have learned QPSK and all, and we like a higher version is there. Okay, 64 QAM, 256 QAM, all like is there. So that means what? One signal to represent one signal, you are using 252 to the power so and so. Okay, 64
Excuse me, ma'am.
is that? Yeah.
Hello, ma'am. The screen is not visible, ma'am.
Which section is it?
Sorry, ma'am.
Which section you are?
A section, ma'am.
A section.
Yes, ma'am.
Now it went. How is it? I didn't do
Your
anything.
your your
Auto,
voice is breaking.
my voice is breaking.
I don't know. It's for all, but for me it is like
Okay, tell me. Was it not visible from the beginning?
it was, ma'am. Now like I can see only black screen. Before it was stuck, ma'am. For
Is it?
yes,
Okay,
ma'am.
others, what's your name?
Gautam, ma'am. Gautam.
Gautam, Gautam. Others can just unmute and answer. Is it visible or no? Because I didn't do anything.
It's not visible, ma'am. It's a black screen.
It is a black screen. Okay, B section people. Kshama. Array. All of a sudden, what happened? That's what I'm not changing. I'm not changing. It is like a theory, no? So I'm just giving the introduction. That's it.
Like your voice is also breaking, ma'am.
Is it?
Yes, ma'am.
1 second. See, the screen is actually energy usage profile.
Yeah, it was
Okay.
stuck there only, ma'am.
Yeah, it is not stuck. I have kept it there only.
Ah, now it is black screen, ma'am. Now we can't see anything.
It is black.
Yes, ma'am.
Okay, okay. Let me see. 1 second. This is actually B section. For B section is